Hi, I'm Ms. Milkowski, the mathematician, and today we are going to do a problem where we find the possible measures of the third side of a triangle. And we're going to take it one step further by seeing if we can find the possible measures of the third side if that triangle is obtuse. So let's take a look at this problem. You are given triangle ABC. AB equals 5 and BC equals 12. What are the possible measures of AC? And what are the possible measures of AC if the triangle is obtuse? Okay, so first thing I'm going to tell you to do is click pause, attempt this problem yourself, and then we'll do it together. All right, so now we're back. So let's think about this. All right, so first we might want to just draw, a quick little picture, okay? That'll just kind of help us visualize this. So I'm going to draw an obtuse triangle. And let's see, we'll call this A, B, and C. Okay, so AB is 5, BC is 12, and we'll call AC X. Now, obviously, let me make that X a little bit better. Obviously, this is not drawn to scale, okay? All right. So, I'm just going to use X for AC just because it'll make it easier to do some math. Okay, so if we want to find the possible measures of AC, of that side, okay, we know that it's just going to be less than the sum of the other two sides, so 12 plus 5, and greater than the difference of the two sides, so 12 minus 5. Okay, so 12 minus 5 is 7, and 12 plus 5 is 17. Perfect. So that side, and we can write it one more time, replacing X with AC. So the measure of AC is going to be less than 17, but greater than 7, okay? So these are the possible measures of AC. So somewhere between 7 and 17. Now, I know I did that quickly. I do have a video. You can click right there and you can watch a video of me doing a problem just like this out in full. Okay, but I want to save some time because here's the big question. What are the possible measures of AC if the triangle is obtuse? All right, so I have decided to use some manipulatives to help us understand this because I could just tell you, well, you know that the square of the longest side is going to be greater than the sum of the squares of the two shorter sides. I could say that, but that would be memorization. And do we really understand what's going on? And what if we mess up? And what if we think that it's less than? Or what if we think that it's equal? Or who knows, right? But if we understand what's going on behind the scenes, if we ask ourselves, why is that the case? Then we truly get it. We don't need to memorize anything, right? Okay, so before I show you this stuff with manipulatives, I just cut out, some pieces of paper to illustrate something. I want to talk about what if the triangle were right, okay? So I am going to erase this, okay? Now, before I draw my right triangles, all right, there's something that I need you to know. Actually, I'm going to erase this as well, just so that we have more room, okay? I'm going to move it kind of up here, okay? So, we know that AC was less than 17, but greater than 7, okay? Boom. So we're going to keep that boxed so we know that's where it must fall, okay? So now we have two options. AC can be the longest side, okay? So we'll write AC is the longest side. Okay, AC is the longest side, or our other option is that, what? BC is the longest side, okay? So the other option is, maybe I'll put it right down here. Okay, so BC is the longest side. Okay? All right, so if AC is the longest side, now remember, we're going to look at right triangles first, okay? So if AC is the longest side, if I make a right triangle, okay, I know that this is 5, this is 12, okay? So this was A, B, and C, okay? I want to know what this side's going to be. So I can just use the Pythagorean theorem, okay? So I will say 5 squared plus 12 squared equals x squared, okay? So 5 squared plus 12 squared, that's going to be 25 plus 144 equals x squared. So 169 equals x squared. Good. So x equals 13. Okay, so AC is 13. So I'm going to erase X right now, okay? And I'm going to write 13 there. Okay. Whoops, that doesn't stay too well there. Okay, so I'm going to write 13. Okay, so in this case, all right, if it's a right triangle, I'll mark that off as a 90-degree angle. If it's a right triangle, AC would be 13. We don't want it to be right, though. We want it to be obtuse, and you're going to take a look at that in a minute, okay? But for right now, think about it. If it were right, AC would be 13, okay? Now, I'll just box that so you can see it. Okay, now, BC is the longest side, okay? So that means BC is the longest side. So we have to think about, we'll redo our triangle here. I'll just draw another triangle. So this is BC, so I guess I'll start down here, A, B, C. Okay, so AB is 5, AC we don't know, and BC we know is 12. Okay, so BC is the longest side. So again, we're just going to use the Pythagorean theorem, so we'll do this super fast. So 5 squared plus x squared equals 12 squared. Okay, so 25 plus x squared equals 144. So x squared, subtracting 25 from both sides, x squared equals 119. So x equals the square root of 119. Perfect. Okay. All right, so that means this is the square root of 119. So I'm going to erase that. Okay? And I'm going to write the square root of 119. All right. Perfect. All right, so I want you to keep these two triangles in mind, and I do have them redrawn for when I use the manipulatives, but I think it's important for you to understand where those came from, okay? I just used Pythag to find if they were right triangles and AC was the longest side, AC is 13. If they were right, or if it was a right triangle and BC was the longest side, AC, which is the side we don't know, would be the square root of 119. All right, so take a look at what I do with the manipulatives, and then we're gonna return here.
Now it's time to use some manipulatives. So as you can see, I have triangle ABC here, and I've drawn it as a right triangle because that's where we're going to start. So we're going to say, so if you recall, we know that overall the triangle AC, the side of AC is going to have to be greater than 7 but less than 17. So here's the case where AC is the longest side, and we're going to start with the right triangle, and you're going to see why. Okay, so I made these sides, and they are drawn to scale. I measured them out. So AB is 5 centimeters, BC is 12 centimeters, okay, and AC is 13 centimeters. Okay, because we're now trying to find the lengths of AC if the triangle is obtuse. So we start with a right triangle, and we say if it's a right triangle and AC is the longest side, it's got to be 13. Okay, it's got to be 13. But we don't want a right triangle. We want an obtuse triangle, right? So we are going to kick outside BC. We are going to make that right angle that we started with, we're going to make it obtuse. Okay, so here this is 90, but then I kicked it out, so I added, some more degrees to that. So now it's greater than 90, which means this triangle is obtuse. Well, remember, AB is 5, BC is 12. I can't change those measures, but I need to complete this triangle. So what I'm going to have to do is I'm going to have to bring AC down, but as you can see, if I bring it all the way down, it cuts into 12, and that can't happen, right? Because I need it to be 12 centimeters, because that's given. So what I have to do instead, okay, is I have to make AC longer. So I can make it a little bit longer by adding in this piece of pink here, okay? So as you can see, AC, if the triangle is obtuse, AC needs to be longer than 13 centimeters because in order to reach to side BC, okay, it has to be longer. All right, so that's how we know in the case where AC is the longest side that it must be greater than 13 centimeters. Okay, now obviously it can't be 17 is the max it could be, because if we were to make this super duper duper obtuse and imagine bringing this down, 13 would just get longer and longer and longer and longer, and it would stop obviously at 17, because then this would be a straight line. Okay, so it can be less than 17, or must be less than 17. So as you can see, okay, so I'll do it again. When AC is the longest side and we kick out the side, we need to we need to make AC longer than 13 because it won't reach unless it's longer. Because if I were to keep it at 13, it would cut off 12, and 12 has to stay the way it is because it's given. So I just bring in a little extender, okay? And there you go. Now, just so you know that it would work for either side, I could also kick out from side AB, okay? Same situation, this used to be a right angle, I kicked it out, so now it's obtuse. And oh no, it doesn't make it. What do I have to do? I have to bring in more, okay? I have to extend the length of AC and it has to be greater than 13. So that's how we know in this specific case, AC is gonna have to be greater than 13, but then of course the main restriction is that it must be less than 17, so it'll be between 13 and 17 if AC is the longest side. Now, here's the case where BC is the longest side, okay? So again, I have triangle ABC, but BC is now the longest side, okay? And remember, I know that AB is 5, BC is 12, and I want to know the possible lengths of AC when the triangle is obtuse. So I'm going to bring these together here. Okay, perfect. So we're going to start with the case of it's a right triangle, okay? So in a right triangle, if BC is the longest side, AC is going to have to be root 119, sorry, not root 19, root 119, all right? But we don't want it to be a right triangle. We want it to be an obtuse triangle. So what are we going to do? Okay, we are going to kick out the side to make it obtuse, okay? There we go. So I just kicked it out. So instead of a right triangle here, this is now obtuse, okay? Now obtuse, all right? So I need to connect it because obviously this isn't a triangle right now. So what I'm going to do is I'm going to bring down the 12, okay? And this is a case where it's going to end up cutting into the 119, okay? Because remember what I said, that the two green sides, the 5 and the 12, they are given to us. They are 5 and 12. We can't change them. We can't manipulate them. The thing we can change is the length of AC. We can make it longer. We can make it shorter, okay? Well, in this case, we're going to have to cut some of it off. We're going to have to chop this part off, which means it's going to have to be less than 119. Okay, it's going to have to be less than 119. So for this specific case, we are dealing when we make an obtuse triangle and BC is the longest side. AC is going to have to be less than the square root of 119. Because when it is the square root of 119, it's a right triangle, but because we want that obtuse angle, okay, and because 12 and 5 have to stay the same, when we bring 12 down to connect it, to complete the triangle, we have to chop off here, boop, see you later, part of AC, so it's going to have to be less than the square root of 119. So therefore, when BC is the longest side, okay, and we want an obtuse triangle, AC must be less than the square root of 119. And then again, there was that original restriction where it has to be greater than 7. So there you go.
Okay, welcome back. So hopefully those manipulatives helped you understand the concept of finding the possible measures of AC if the triangle is obtuse. So let's think about it again for a second. So I wrote down, this is where we're going to write if the triangle is obtuse, you know, what those measures would be, okay? So let's think about it. So here was our right triangle, and what you saw me do was I opened it up to be an obtuse angle, and what happened? It had to be bigger than 13. If it's a right triangle, AC could be 13 and that works. But if it's an obtuse triangle, boop, we opened it up and this needs to be longer to connect. Okay, so therefore we know that AC must be greater than 13, because if it is 13, it's going to be right, and anything greater, that's when we created that obtuse angle. Okay, perfect. Now we come back up here. We remember originally what the possible measures were of AC, and that was it had to be greater than 7 but less than 17. So we know it has to still be less than 17, okay? AC must be less than 17, but it has to be, because we know that's the greatest measure it can have, all right? So therefore we know, since it has to be greater than 13 if it's obtuse, it's got to be less than 17 because that was our initial restriction. So we know that if it's obtuse and AC is the longest side, then AC must be between 13 and 17. Okay, now I'm just gonna write over here, like if obtuse, I probably should say if obtuse, colon, oh, I forgot the E, whoops, okay. If obtuse, AC is the longest side, AC is between these, and okay, so now BC, so let's think about that again. So again, what happened there was I opened it up, and as you saw, this 12 had to kind of come in and cut this side shorter, okay? So we know that, oops, need the correct color marker here. We know that AC's got to be less than 119, because when we opened up that angle, this BC side kind of came in and chopped this 119 to be a little bit shorter. So we know that in this case, AC is going to be less than the square root of 119. I'm sorry, I think I was saying 119 before, but you knew what I meant. I meant the square root of 119, okay? So AC is going to have to be less than the square root of 119, okay? Because when we open that angle up, this has to come in and chop that side, okay? What must it be greater than? Okay? 7, okay? Okay, so it can't be any less than 7, it has to be greater than 7, so there you go. So if the longest side is BC, then AC must be between 7 and the square root of 119. All right, so this was good. I kind of organized stuff over here, but I'm going to erase this because we want to do, again, I don't know how much your teacher might accept this and say, well, you wrote if obtuse, and then here are the 2 answers, because remember, it's going to be 2 possible answers. And then this is the general, what are the possible measures, okay? So let's just to be safe, because every teacher has different things that they want, okay? What I'm about to write here would be our kind of like our final answer, okay? So what are the possible measures of AC? Okay, so there you go with it kind of a little bit more organized there. Always good. This may be acceptable. I mean, I do think we kind of showed what stuff was really well over here, but you just don't know what your teacher could want. So you can ask them, I mean, how am I supposed to show this? You know what I mean? They'll tell you. So there you go. Hey everyone, I'm Ms. Milkowski, the mathematician, and I hope you found that last video helpful. If you have any questions or if there are any topics you'd like to see me cover in future videos, definitely let me know in the comments below. Thank you again for watching. I hope you have a wonderful day, and I'm going to leave you with the most important piece of advice I can give you, which is when you're doing mathematics, always ask why.